In this lesson we're going to look at what the magnitude of a vector is, how to represent it, and also how to calculate it. So the magnitude of a vector is actually the size of it. What value does it represent? So if you're talking about the speed aspect of a vector, then you can calculate this just by working out the length of the vector. And we can do this really easily from previous knowledge in maths. So the notation used for the magnitude is these two lines either side. Now you can write this using your small case letter. Remember to underline this. I've got these in bold, but you would have it underlined, or you can use your AB notation with your line across the top with two lines down either side. So the question here is find the magnitude of u, that's how this is read, if u is 4, 3. So this is what the vector would look like, and you would think 4 along and 3 up. Now what we've done here is we've created a wee triangle, 4 along and 3 up. So to calculate the length of the vector, or the magnitude of it, you can do a bit of Pythagoras. So 4 squared plus 3 squared and square root is 5, or it's a Pythagorean triple, 3, 4, 5 triangle. So a bit of Pythagoras in one line, and you end up with 5 units. And this works for any vector AB. Then to work out PQ, the direct line segment, the magnitude of it, you square root it and square the two things and add them together. Square the two components. And that's it. So, having a look at this, there's 3 examples. State the components and magnitude of each vector. So the components of this first vector, we start here and we go along and then up, because the vector is moving in this direction, up diagonally. So 1, 2, 3, 4, 5, 6 along and 3 up, so 6, 3. Magnitude, square root of 6 squared plus 3 squared. So that's 36 plus 9, which is 45. Break it up into square root of 9, square root of 5, which is 3 root of 5. Again, remember I've got these in bold, so remember to underline them in your textbooks. Components of BC, starting at B, so we go backwards this time, so that's negative 2 and up 3. So negative 2, 3. Magnitude is the square root of negative 2 squared plus 3 squared. That's going to go to 4 plus 9, which is root 13 units. And the last one here, starting up here, because we're travelling down in this direction. So we go along first, backwards, 1, 2, 3, 4, 5, 6, 7, 8, so negative 8, and down 4, so that's negative 4. To get the magnitude, square 8, or square negative 8 and square negative 4 and square root it. So that's going to be 64 and 16, which is 80. Again, break it up into root 16 times root 5. You're looking for the biggest square number that goes into these to simplify thirds. And that goes to 4 root 5 units. Okay, just to move on a wee section, we'll look at how to draw line segments. So if we're to draw P, you would do a dot, and then you would move 2 back and 4 up. So move that down actually. So 2 back and 4 up, and then you would join it up. And we're going in that direction there, and you could label that as P. And I'll put it as bold, but you guys would underline your jotters. And you can do all the other ones exactly the same. I'll do negative 3, negative 6. So starting at a point, and we'll go back negative 3 and down 6. So we're starting up here and going down the way. So this is our direction, and we're calling this one Y. I'll just take that. and just underline that one, so change, and there we go. Now if I was to draw 2 line segments for 2, 1, then I'll do that quickly. So starting here, and 2, 1 means 2 along, 1 up. So 2 along, 1 up. That would be your vector. If I was to draw another one, 2 along and 1 up, you can see that they're exactly the same. Which leads us to our last point in this lesson, talking about the equal vector which has equal components. So it says here, each of these journeys has the same distance and same direction, and so represent the same vector. All these journeys are 2 along, 3 up, 2 along, 3 up. So equal vectors have equal components. I think that's fairly obvious.